SESAME is a synchrotron light for experimental science and applications in the Middle East. It's a center of excellence based on synchrotron light radiation. Is the exception, not the rule, of having really such an advanced scientific center of research in the Middle East. All the facilities in SESAME are powered by solar energy. And we reached the full energy of 2.5 giga electron volt in the storage ring of SESAME.
By accelerating electrons at the speed of light, we produce beams which are used in these instruments, which we call beamlines. According to the kind of wavelength, the kind of energy you are using, there are different informations that you get from the samples. You can ask for the chemistry of the sample, for the structure of the sample, for the microstructure of the sample, do imaging, spectroscopies. These kind of techniques are so wide, so flexible, that they attract any kind of science which needs information on a material can benefit of this kind of facility.
BEATS is a consortium of European and Middle East research labs that they joined together to build a tomography beamline at SESAME. BEATS is a project that they have three pillars. The first pillar is a collaborative joint effort of all the big members to tailor the design, the procurement and installation of all the beamline instrumentation. The second pillar is the multilateral exchange of ideas, transfer of knowledge, bidirectionally. It's not just bringing here technology to be used in a region, but it's just bringing technology that will use export as well to Europe. And the third pillar is the sustainability of the beamline operation in long term, after the BEATS end of the project. So the establishment of a user community to exploit the instrument.
It's not only just building the equipment, which is fine, which is really great, but also it is building relationships between different parties. Yeah, already benefit from this collaboration because we gain a lot of knowledge about the tomography beamline, about the installation, about the commissioning. So I think that it is a win-win situation for both parties.
BEATS is a computed tomography beamline, an X-ray tomography beamline. So it uses X-rays to do imaging in 3 dimensions. The goal is to investigate, visualize and characterize the internal microstructure and composition of objects and samples down with a resolution of less than 1 micron, 0.65 micron. And we can do that on samples that range from cultural heritage and archaeology. We can do it on fossils, on biological tissues. We can study earth and soil samples. It's a 3D technology which is completely non-invasive, so we don't have to destroy the sample to see inside.
You know, scanning a sample over here can take few seconds to minutes, while in my lab it takes few hours. So, you know, the shortness in time and the high resolution and the capability of doing 4D, which means that you can capture dynamic processes in your sample while being scanned, is something that I expect and is possible to be done over here.
This facility, SESAME and the BEATS tomography, that brings not only the samples together, but also the scholars together. And BEATS being in the heart of the Near East, in the heart of the Middle East, that is extremely important for the archaeologists and the cultural heritage specialists in this region. That will give us the cutting-edge science at home.
This is really a big success story, and it really puts SESAME's capabilities and potential on a much higher level. We have 5 beamlines which will be operating starting from today. We'll be receiving users from all over the world. The key message I have for scientists in this region and globally: always be an optimist and always work together. Collaborative effort is the key for success, not just when it comes to world-class science, not just within a country or a region, but collaborative work on a world scale will really produce world-class science.